Hello everyone! In this video I am going to show you how I made a real gold-plated cup. To make it, I am going to resort to galvanic gold plating, which is coating some material in a layer of fine gold. I am going to use my stainless steel backpacking cup as a base metal. Now, what's left to do is to find some pure gold for making an anode and gold-containing solution. What about this gold bracelet I was given as a gift a long time ago? Since I am not a lover of jewelry, I think such great gold shouldn't be aimlessly lying around. That is why, without any hesitation, I reduce this bracelet to small bits in order to make it easier to later dissolve it in aqua regia. There are about 6 grams of pure gold in this bracelet, along with some silver and copper, and I just need to separate them from each other. That's quite simple. First, I'm preparing a mixture of 30 ml of 35% hydrochloric acid and 10 ml of 65% nitric acid, which is also called aqua regia. After making the mixture, I am immersing my gold bracelet chains in this solution. Upon being heated up, the alloy of gold, silver and copper actively starts to dissolve in the aqua regia. When stirred, the process runs even faster, because the forming silver chloride is quickly removed from the surface of gold, preventing it from passivating the surface and stopping the reaction. From a chemistry point of view, under the influence of nitric and hydrochloric acids, gold is oxidized to chloroauric acid. Along with that, silver and copper present in the bracelet are also oxidized to copper chloride and silver chloride. After adding some water, it took additionally about 2 hours to fully dissolve the gold chain. After that, the solution became bright green because of the copper chloride and chloroauric acid present in it. First, I added a little bit of sulfamic acid into the beaker in order to get rid of the leftover nitric acid in the solution and to make it easier to extract gold from the solution. On the bottom, there are some silver chloride and gold particles which have not reacted yet. We need to separate them from the rest of the solution and dissolve them too in aqua regia. I am removing the unnecessary silver chloride from the solution with the help of sodium thiosulfate, which forms water-dissolvable complex with silver chloride, and then dissolving the leftover gold alloy in aqua regia. Now it's time to extract pure gold from this solution with the help of adding sodium metabisulfite. It's better to conduct gold depositing in a heated solution in order for the gold particles to better stick to each other and make it easier to filter them. It's also better to use dry sodium metabisulfite rather than a solution. A lot of sulfur dioxide is released during this reaction. That is why such an experiment should be conducted either outdoors or in a fume hood. Then I am rinsing the extracted gold several times with distilled water and finally got this much gold powder. Now I just need to melt it into a shiny gold bar with the addition of a little borax to the gold powder and start making a gold anode. Which is why I was just beating this gold nugget with a hammer. Because of its softness, the gold got flattened quite fast, but still it cracked at the final stages. In order to give the metal more elasticity and temper it, I kept flattening and heating it with a gas burner. Now I just need to make a gold-containing electrolyte, which is why I took 4 grams of potassium ferrocyanide and dissolved it in 200 ml of water. After that, I added 5 grams of potassium carbonate to decrease the acidity level to about 12 pH. After heating the mixture to 80 degrees Celsius, I'm adding 6 ml of 9% chloroauric acid solution to it. the color is gradually changing, and in order to finish the reaction, I'm going to heat the solution for 30 minutes more. When I'm doing that, exchange reactions are taking place in the solution. Atoms of gold are substituting atoms of iron in the potassium ferrocyanide and are forming potassium hexathionaurate and iron hydroxide sediment. After filtering, I got a pure electrolyte for gold plating. To test my electrolyte, I took 2 steel spoons and connected them to the electrodes of my electricity supply. After that, I applied 3 volts and 200 milliamperes current. As a result, 5 minutes later, the spoon connected to the cathode was coated in an even and beautiful layer of gold. I think now my electrolyte is definitely ready for gold plating. Finally, I have made about 500 ml of electrolyte from 20 ml of chloroauric acid. Basically, everything is ready now for gold plating. I have rinsed my steel cup with water and then left it in 10% hydrochloric acid solution for an hour in order to activate the surface. Now I am immersing the cup into half a liter of electrolyte and also immersing the gold anode into the liquid. Now I just need to connect this setup to a direct current supply. I am going to do gold plating with a low amperage of just 100 milliamperes for several hours. When current is applied to the electrodes, pure gold is deposited on the cathode, which is our cup, and also on its surface hydrogen is being released. Along with that, oxygen is being oxidized on the anode, which is why it is bubbling with oxygen. After 1 hour, I noticed that this method of gold plating doesn't coat evenly, even if the cup is constantly rotated. That is why I evened out the gold plated on the cup with steel wool. After that, I diluted the electrolyte with water in order to allow it to cover more surface. Now the cup will be gold plated more evenly, but it will take much more time because the electrolyte has been diluted. I left the cup in the solution for 12 hours and in the end it was coated in a thin and more or less even layer of pure gold. In the end, we got a beautiful looking cup plated with 24 karat pure gold. For me, it looks very amazing. So, if you like this video and if you want to see more experiments with gold, don't forget to give this video a thumbs up and subscribe to my channel to see many more new and interesting